there will be a industry. Okay, for that industry, okay, there will be a two input. One is the labor requirement, then another one is raw material requirement. Okay, in order to produce the output, model A, model B, model C. What we need to do? We need to maximize the function Z. Z is what? It is the objective function we are going to consider. Okay, for these, the decision making is what? These A, B, C. Okay, we are going to define these as x1, x2, x3. Okay, by the make use of these availability of the resources which are available in order to formulate the linear programming model. Okay, means there will be a requirement of to model A, then there will be a 7 hours per unit. Then raw material is required 4. Okay, then similar to that, which is to be present. What you are going to defining with respect to this? The decision making variables to be defined as x1, x2, x3. This is the concept. In order to maximize what? The objective function. So that you can make use of first step is identify the decision variables. Okay, what is that decision variables? There will be a x1, x2, x3 be the daily production rate of the models A, B, C respectively. It means that here the whatever the model is there, I need to produce this model. I want x1 as a variable, x2 as a variable, x3 as a variable in order to produce for model A, model B, model C that you are considering. What is the constraint? 150 and 200 is the constraint. It should not going to exceed those values. Okay, that is your first step. Identify the decision variables and represent them as the algebraic symbol. Algebraic symbol can be used as x1, x2, x3 that you can concentrate. Okay, let I have taken as x1, x2, x3 daily production rate of model A, B, C respectively. Copy this. Next, what is the constraint here in this problem? How we are going to use the labor, how we are going to use the raw material is the constraint. That is your second step. Identify the constraints in the problem. Okay, the constraints are on the availability of labor hours per unit and the raw material pound per unit. Copied. Because in my PDF, if I written now, it is not clear, so that I am using this paint. Is this comfortable for you now, screen?
Yes, sir.
Okay. Okay, these are what they identifying. Then next I will use this only. Okay, what you are defined? Labor, then raw material. Okay, what is this constraint? That is, this is x1, this is x2, this is x3. Okay, these are what the variable with respect to that of constraints of 150, then 200. Because for these two are to be used to make production of A, production of B, production of C. So that we have taken this production itself is as a x1 variable, x2 variable, x3 variable. So that we have defined that itself is what? The identifying of the decision making variables. Later, constraint is what? Okay, the value is should not exceed this value. It means the 7x 7x1 plus 3x2 plus 6x3 is less than or equal to 150. It means I need to use the labor per hour will be of 150 only. It means which is equal to 150 also be okay. If it is less than 150 also be okay. So that 7x1 plus 3x2 plus 6x3 less than or equal to 150. Okay, means this value is not exceed this 150. It should be less than that value in order to produce the A, B, C models. Because collectively we are using in the industry. Because of that reason, that sum of using those constraints as per the requirement in order to produce the models. That is what the identification of constraints in the problem. Got my point? That will be defined here. Okay, labor requirement 7x1 plus 3x2 plus 6x3 less than or equal to 150. This is what labor availability. Okay, if it is less than 150 means it is good. Then raw material what which it is required is what? 4x1, 4x2 plus 5x3 is less than or equal to 200. Because they have defined here the constraints. Keep this is in mind. Raw material pound per unit 4, 4, 5. Okay, but this should not exceed the constraints of 200. Keep that is in mind. Okay, according to that 4x1 plus 4x2 plus 5x3 less than or equal to 200. This is the material. Copy this. Okay, this completes the second step. Okay, this is regarding to what? Identification of constraints which is there in the problem, what they have defined. Okay, what is the intention? What is your objective? In order to maximize profitability. So that is the third step. Third step is what? Identify the objective of the function. Whatever problem which it is there, in that you have to define the objective function. Okay, the objective is to that maximize the profit. Okay, what is the maximization? Here, I need to increase this profit means they are defined. Model A should be of 4 rupees, 4 pound. Then model B should be produce 3 pound, that is 2 pounds. Then model C has to produce the 3 pounds. Okay, this is profit we can expect from model A, model B and model 3. Okay, I need to maximize this one. So that I defined Z as a objective function. Okay, max of Z is equal to, okay, 4x1 plus 4x2 plus 4x3. It means that how many models you are going to define for A, how many models you are going to define for B, how many models you are going to define for C. That itself will maximize the profitability of component which is to be designed by the effective utilization of the labors, by the effective utilization of the raw material. Okay, this is your third step. Copy this. Okay, then for this, you have to write the LPP model. Okay, thus the LPP model for the given problem is, what is that model you have to do? That is maximize the profitability 4x1 plus 2x2 plus 3x3 subjected to constraints. That is 7x1 plus 3x2 plus 6x3 should be less than or equal to 150, because whatever labor hours you are going to use, that should be less than or equal to 150. Second constraint is what? What is the raw material you are going to use? this raw material should not exceed the 200. Okay, that is 4x1 then plus 2x2 plus 3x3 less than or equal to 200. 2 or 4 it is?
The raw materials of 4x1 plus 4x2 plus 5x3.
Correct. This is 4. This is 4. 4x2 plus 3x3 less than or equal to 200. Subject is what?
X3 to
These should
5
not be negative values. These should not be what? Negative values. Okay, these things you can concentrate. Okay, this is 5. Sorry. This is 5x3. Okay, this is 4x2. Modify that. 4x1. Now it's correct. But these x1, x2 values are what? Non-negative values. This is what the modeling of linear programming problems. Okay, this is how you need to make the construction of the linear programming model, which is to be used as a variable identification. Okay, one more thing you remember, whatever numerical they defined, read it properly. In that, what you are taking as an objective decision variable based on the objective of the function. Okay, there will be a minimization they will give, there will be a maximization they will give. According to that only you can solve the numerical. Okay, then another one is also be there. Okay, once you can go through this notes. Okay, then remaining type of problems I will discuss that in next class. Okay, that is here where we can use this linear programming application. Okay, where there will be a complexity is there we can use the linear programming problems, especially in case of transportation problem, then diet problem, matrix games, then portfolio optimization, then crew scheduling. Okay, in order to minimize or in order to maximize. Okay, in all these cases, these mathematical models are most commonly using. Okay, based on the requirement, what is it to be required, designed for that problem, what type of variable you have to be taken as a decision variable, it is left to you. But the constraints, what is it defined, you should not be vary that, because those constraints are already defining in the numerical itself. Okay, so that by considering that numerical consideration only, those decisions to be taken care. Okay, these things you can concentrate. Okay, then remaining type of numericals are available. Once you can go through this. Okay, here. There will be a manufacturing produces the two types of models, M1 and M2. Each model type is M1 require 4 hours of grinding, 2 hours polishing. Okay, whereas model M2 require 2 hour grinding, 5 hour polishing. But the manufacturing will have 2 grinders, 3 polisher. Each grinder works 40 hours in a week. Each polisher works 60 hours in a week. The profit on M1 model is 3 rupees. Then model M2 is 4 rupees. Where is the produced in a week? Okay, whatever you are going to produce in a week is sold in the market. Okay, whatever the model you are going to design, M1 and M2 are to be sold in the market itself. How should you manufacturer allocate his production capacity two types of models so that he may make maximum profit? Okay, this is related to what? Maximization objectives. Okay, what is the decision variable? X1 and X2 are what? How many units are there? Those are what? The X1 and X2. Okay, objective function is what? We need to get the profit from model 1, 3 rupees, then model 2, 3 rupees. max of z equal to 3x1, 4x2. What is the constraint here? They are not given directly 200 hours, 150 hours. Okay, there will be two functionalities are there here. Okay, what are those functionality? One is grinding, then another one is polishing. Okay, so that the number of hours which is to be available each grinder in a week is 40. Okay, two grinders are used. Okay, then manufacturer does not have the whatever the values to be required per unit. 2 into 40 is 8 hours. Then grinding M2 will require 4 hours grinding. Then M2 will require 2 hour grinding. So that 4 plus 4x1 plus 2x2 is less than or equal to 80. This is what grinding constraint. Then another one is what polishing constraint is also be there. One more is what the polishing constraint. Okay, that also you can consider. How many polishers are there? 3 polishers are there. Okay, their availability in a week is that 3 into 60, because in a week 60 hours is there. 3 polishers are there. 3 into 60 is what? 80. That is 180. Okay, with respect to that individual, for model 1, 2 hours is required. For model 2, 5 hours is required. Hence, we have 2x1 plus 5x2 less than or equal to 80. So that maximize Z 3 of 3x1 plus 4x2. Subjected to constant is what? Okay, how many hours you will use for grinding to make the production of model 1, which is to be defined as the variable x1. Then M2 is what? The variable as x2. Okay, for these two, 3x1 plus 4x2, because from model 1 I have to get 3 rupees profit, from model 2 I have to get 4 rupees profit. What is the condition for my maximization of that profit? 3x1 plus 4x2, subjected to effective utilization of grinders and the polishers. Means the whatever hours it is there, complete hour I have to make utilization for modeling of model 1, then model 2. With respect to that, 4x1 plus 2x2 is less than or equal to 80. Then 2x1 plus 5x2 less than or equal to 180. Subject is what? Condition. The x1 and x2 are non-negative values. Keep this is in mind. Okay, it should be greater than or equal to 0. Okay, this is how you need to follow with respect to that of the problem solution. All of you got my point? What I explained here? Is this clear?
Yes, sir.
Understood?
Yes, sir.
Okay, here problem formulation is very easy here. But you have to understand what parameter you are taking as a decision variable. That is very important. Okay, what is the product it is there that you have to take as a decision variable. For that production, what are the things you are considering as a input? Okay, those are to be considered in consideration of the constraints. That relation, if you are defined, that itself is called as the mathematical model. Okay, then you can see here the whatever expressions are there, all these are linear equations, not the linear, non-linear equations. Keep that is in mind. That's why it is called as linear programming problem models. Okay, this is very important for the examination point of view in how to model for the given numerical, that you can remember.